Stan Gibilisco here to describe alternating and direct current combined. Alternating current, in this case being the sine wave, and in this particular illustration there is no direct current component because the positive peak voltage and the negative peak voltage of this wave are the same. But when you add a DC component, and let's suppose we add a positive DC component to this alternating current wave, we simply raise the wave like this. Now this is still alternating current technically because it changes polarity periodically. Sometimes it's negative, as in down here, and most of the time here it's positive. So it's still alternating current. It's still alternating current. But when the negative peak of the alternating current wave reaches zero, like this, it is no longer technically alternating current, even though it has the exact same wave shape. That wave shape is elevated in such a way that the polarity never reverses. It does get down to zero for points in time, but it never gets negative. In this case, now we could just as easily have gone negative instead of positive, but I put these labels down here for a reason. I didn't want to run the wave down over them. If we continue to elevate the wave, add more and more of a DC component, then we get negative peaks that actually never even get to zero. The minimum voltage is here, and the positive maximum voltage points are here and here, but the waveform itself is identical. Now this is what you might see and on the collector of an amplifier designed to, say, make a radio frequency carrier stronger, or make an audio sine wave tone stronger, or something like that. You will see the DC component of the bias on the collector, which is the average value of this wave, so the DC component is right about there, and then you will see the wave like that. Now you don't want that to actually go into your output device like a speaker, for example, or antenna, because the DC doesn't contribute anything to the signal. In fact, it can detract by dissipating power in a speaker, for example. So you want to get rid of that DC component. You can do that with a blocking capacitor, and then once again get the output like that. So this is alternating current, still AC but now with a DC component, AC with a DC component, AC with a DC component. But now, when the negative wave peaks reach zero, what we really have is DC, which is the average here, with an AC component. It's pulsating or fluctuating direct current, but it is no longer alternating current. So as we continue to add more DC voltage, we get DC with an AC component, whereas here we have, for example, AC with a DC component. Kind of a weird way to put it. I don't know if I've ever heard anybody else put it like that, but of course I like to do things for the first time if possible, so that you can get a little better idea of the gist of it all. But this, once again, is pure alternating current. When the average, in the case of a sine wave, the average voltage is zero. You add DC component to that wave, the average voltage is equal to that DC component, if this is a sine wave. Not necessarily true for other waveforms, though. You continue to increase. Now, once again, we have DC, that much DC right there, with an AC component. So that all of these kinds of situations commonly occur in electronics. And now you know at least what to call them, or at least what I call them. I, being Stan Gibilisco, proprietor and operator, by the way, of amateur radio station W1GV, Whiskey 1, Good Vibrations, saying 73, which means ham radio, in ham radio jargon, means best regards, and so long for now.